Hello everyone, Doug Simonian over at New York Metro Weather with your latest video discussion. Obviously, the main subject today is going to be the powerful nor'easter that's going to be impacting the entire Northeast. And we'll get started by taking a look at the latest GOES-16 satellite imagery. This is actually the infrared imagery on NextLab. And of course, we don't want to take too long of a look at time-sensitive images, such as current satellite, current temperatures, current radar, because, you may be watching this video, a few hours after I record this, so some of the, the current images may not be valid when you're watching. I'm recording this video at 6:40 a.m., but of course, it's still important to get a look at the current conditions for context. And we can see that on the satellite, the storm is beautifully developing. We even see already a comma head type look taking shape, and we see the explosive convection well off into the Atlantic towards the Gulf Stream with these rapidly rising cloud tops. We see the fire hose low-level jets start to form as the pivoting occurs and as the storm runs into some resistance from the north. That's why you see the pivoting occurring anyway, because it can't continue to gain latitude so quickly as it's running into the blocking pattern. So as it gets compressed, so to speak, you enhance the gradient, and thus that fire hose low-level jet starts to pinwheel and explode into coastal New England, where they can get some 70-mile-an-hour wind gusts and severe coastal flooding. Some of that coastal flooding will get into the New Jersey shore waters and some of the New York City coastal waters as well, but not to the same extent as it is in New England due to the orientation of the low-level jet. But clearly we can see a lot of these features very well defined on the latest satellite imagery. This is the current 850 millibar temperatures on the SPC meso analysis. So the temperature's a little bit above our heads, and we can see that it's still a little bit warm in northeast New Jersey, New York City, and eastward. They're east of the zero line, so of course it's still too warm for snow in those locations, but the freezing line is not that far away. Northern New York City suburbs are already starting to mix with snow as a result of this. And with the zero line not being that far away, it may not take that much longer in the form of heavy precipitation to lead to dynamic and evaporational cooling. The lift in the atmosphere leads to lowering pressures, and that leads to inherently cooler air. So that is certainly something we're going to be watching for as the morning progresses into the early afternoon. And at 9 to 25 millibars, it's still a little bit warm in New Jersey and New York City and Long Island. But again, the zero line is not too far away. 9 to 25 millibars is a little lower than 850, but still a little bit above our heads. So, and also we see the wind barbs at the 9 and 25 millibars are northerly, and they're perpendicular to the isotherms, and that usually means you're advecting it very efficiently. So we see very efficient cold air advection because the wind barbs are blowing perpendicular to the isotherms, which means that we are quote-unquote blowing those cold temperatures southward very efficiently. So we will continue to see cold air advection throughout the morning and rain change to snow from northwest to southeast, or maybe even in some cases from northeast to southwest, depending on the orientation of the banding. Now we'll take a look more just like the model data at 500 millibars in the middle of the atmosphere. We see that this is from the NAM model. We see that the 500 millibar low, so this is the middle of the atmosphere, it becomes very intense and just kind of it turns to a large rotating low off the coast that expands, and you get bands pivoting on the northwest side of it. Notice the blocking to the north helps the storm stall. So you get the storm's entire life cycle occur off the coast. It's really very impressive evolution on the models. We see 700 millibars, which is also the middle of the atmosphere, but a little bit lower. This is where we look at to see some the banding signatures. Look at the 700 millibar low. The lowest of it is just off of our coast, and that's usually a very good signal for heavy banding just to its northwest and west, and then that'll be pivoting to the southwest as the storm pivots. Look at this, is the shading is this vorticity, which is just general counterclockwise spin. And in the lower half of the atmosphere, when you're getting a lot of counterclockwise spin, that leads to also a mechanism for lift. So certainly a lot of strong lift is going to be occurring from northeast to southwest, as warm air offshore is quote-unquote colliding with the cooler air on the west and southwest side of the storm. So you're tightening the temperature gradient and leading to more banding. And that is what's occurring later this morning. This image now is valid for 10 a.m. So we see the banding start to pivot in from the northeast to southwest and intensify. And that's when we'll start to see some rain change over to snow, especially for areas away from the immediate New York City area. And we'll get to that very shortly. But still, it's a very impressive signal for heavy banding that continues throughout the morning and through the afternoon. Across New Jersey and Long Island verbatim on the NAM model. And look at southern New Jersey continues to get very much into that heavier banding, and also will be on the cooler side of the storm too. So inland southern New Jersey may get more snow than parts of northeast New Jersey, and of course we'll explain why in a short bit. This is the 3-kilometer NAM model as far as the rain and snow is concerned, and the low pressure. We see that 7 a.m., 8 a.m., 9 a.m. we start to see rain changing over to snow in northwest New Jersey, and locally in some of the heavier precipitation spots in New Jersey, but not widespread yet. 11 a.m. 10 a.m. still mostly rain, but then 11 a.m., noon, 1 p.m., 2 p.m., 3 p.m. there is definitely widespread changeover to heavy wet snow across a decent portion of the area, but also still rain holding on in some spots too. And it's because in the atmosphere that's very what we call borderline, like not really that cold, but maybe just cold enough for snow in some spots. The exact precipitation type, whether it be rain or snow, is very much determined by how heavy the precipitation is. The heavier precipitation will lead to more lift and thus more cooling. So if you're getting into the heavy banding, you'll get some heavy accumulating snow. But in areas where it's lighter in precipitation, it'll be more in the form of rain. So that's why you see the oscillating precipitation types on the 3-kilometer NAM model. But either way, where it is snowing, it comes down pretty heavily. But then when it gets lighter, the snow starts to taper off. We can also take a look at the 3-kilometer NAM model at 500 millibars zoomed in, and we see as the same very impressive evolution of the storm stalling off the coast and pivoting in some nice banding as a result. This is another high-resolution model, the high-resolution Canadian model. It's actually even more impressive in some aspects. At 7 a.m., it's starting to show a changeover to snow in northwest New Jersey. Of course, we'll see if that verifies not too long from now. And then as the morning goes on, the heavy banding pivots from the northeast to the southwest, and thus the changeover to snow can begin. So then by the time we hit 16Z, which is 11 a.m., there's a widespread changeover to heavy wet snow across much of New Jersey and even to parts of Long Island and, of course, the Hudson Valley with heavy wet snow, and that continues throughout the rest of the morning into the early afternoon. And then when the precipitation gets lighter on Long Island, it changes back over to rain. But then when the core of the banding hits southern New Jersey, it actually turns to a widespread band of heavy wet snow. And at that point, more cooler air is also wrapped into the system. So southern New Jersey may be able to more so juxtapose the heavy banding with a slightly cooler air mass. So they may actually be able to get more efficient snow accumulations throughout Friday afternoon. And what's certainly interesting about that is a lot of outlets aren't necessarily forecasting this. And when combined with the potential for very strong winds, there will be blizzard conditions in some spots for the PM commute. We could take a look at some of what we like to call the forecast, well, not their forecast soundings. We'll look at Monmouth County on the NAM model. We see that with the heavy banding taking place, this diagonal line is the freezing line. So if the temperatures in dew point, temperature in red, dew point in green are to the left of that, then it's cold enough for snow. And actually, throughout most of the atmosphere, they're well clear of that. So snowflakes can easily form. And then it's verbatim 34 degrees, but that's such a very small warm layer. The snow would easily last into the ground with such a small and shallow warm layer. But a factor that's, I think, being underplayed is the potential for strong winds. Look at these very strong wind barbs. The shaded triangle is 50 knots, and then the little sticks are 10 knots, and then the smaller stick is 5. So we see 50, 65 knot winds just above our heads. And that's going to be able to mix down to the surface because of the little bit of instability we see. You see the instability is denoted when we see this sharp, negatively sloped lines on the sounding. So you see instability and then the wind barbs just above that. So some of those really strong winds are going to mix down to the surface. There would be some friction and on some reduction, so we're not going to see 65 knot, which is almost hurricane force winds mixing down. But later this afternoon, it's certainly possible that wind gusts widespread over 50 miles per hour throughout almost all of New Jersey, and especially along the coast. Maybe even some isolated 60-mile-an-hour plus wind gusts are likely based on these soundings, and we think these soundings are accurate. So when you combine these very strong winds with the potential for rain changing over to snow, it could certainly lead to some blizzard-like conditions. So really a powerful storm is taking place, and that is why there's some high wind warnings. And these soundings are pretty similar across most of the rest of the state. We'll take a look at the sounding where, at 16Z, which is 11 a.m., we see the heavy snow on parts of Long Island, but then rain in northeast New Jersey. Let's take a look at the sounding during the rain. We see the cold layer, it's not as impressive. Why? Because the precipitation is a little bit lighter. However, you can even argue that the temperatures are still a little bit too warm on this model because during precipitation, where you're getting lift, it should be more saturated. So you could argue that it should be cooler, and it actually could even be snowing. And the sounding could even be a little bit wrong. However, the idea that lighter precipitation means the warm layer is a little thicker and the cold layer is not as impressive. So you notice how the temperature is closer to the freezing line. Certainly gives credence to the idea that there will be rain during the lulls in the action. But still, even on the sounding, we see at the surface there's 30 knot sustained winds. So the winds are really going to be picking up as we head through the morning and into the afternoon. So really a very impressive storm that will be taking place throughout the area, and with oscillating precipitation types. And although the snow will be falling heavily, it may not necessarily accumulate all that efficiently, especially in the city, with the urban heat island effect making the surface temperatures a little bit warmer. Let's take a look again a little bit closer at the high-resolution Canadian model, and we see that even on it, during the lull in the action where the precipitation is lighter, and in between the bands, you get rain in northeast New Jersey, but the heavier snow in southern New Jersey, as actually you still get a little bit of some of the warmer air influence from the ocean that's wrapping in from the low-level jet in northeast New Jersey, but then in southern New Jersey you get more of the backside northwest flow, so you get less influence from the ocean, and you're getting cooler temperatures for heavy banding. So I actually think there could be some 6-inch totals, if not even a little higher, in some inland southern New Jersey spots, especially on the cold surfaces. So really a very impressive storm, and more snow than a lot of the other outlets are forecasting. Just to talk a little bit more about some of the errors the models are having. When it's heavily precipitating, the temperature is supposed to cool off to the dew point. However, on the RPM model, these are the temperatures valid for 19Z, which is 2 p.m. I mean, the 40-degree line is off to the east, but it's pretty warm. It's not that cold at all. So the RPM model was, at least an earlier run, was showing pretty much all rain throughout the area. But look how much cooler the dew point is. So look, the dew points are much cooler than the temperatures at 19Z when there's going to be heavy precipitation. That doesn't make sense. The models are not correctly resolving the temperatures in the low levels of the atmosphere with heavy precipitation, and are thus skewed too warm in the New Jersey and New York City and Hudson Valley areas. So that's why a lot of the models are not showing snow, and a lot of the forecasts from other outlets are not forecasting that much in the way of snow, because they're not realizing these errors the models are having. Even on the HRRR model, which is supposed to be a high-resolution model that takes this into account, this is in north-central Jersey with a little bit of elevation, valid for 1 p.m. Look at this ridiculous boundary layer, 42-degree temperature with a 36-degree dew point. That makes no sense whatsoever in an atmosphere with heavy precipitation and strong lift in the atmosphere. The surface temperature and dew point should be much cooler in a setup such as this one. So the HRRR model is still not figuring this out. It's the only models that have figured this out with the European model, the high-resolution Canadian, and the high-resolution NAM models. The only ones figuring this out. So, although it's not going to be a major event in terms of snow accumulations, there will be some heavy snow falling and potentially accumulating in some areas during its heaviest, and thus, the idea of local 6-inch plus snow amounts in some parts of southern New Jersey. Of course, interior northwest New Jersey could also easily get 6 inches plus. New York City itself may still be only in the 1 to 2, 1 to 3 inch range on the grassy cold surfaces, because again, the urban heat island effect and how they might be in subsidence just northeast of that big southern New Jersey band. You could also get back into more of the snow in parts of western Long Island as well, though not a lot, but enough to certainly make it a wintry feel later this afternoon, with maybe 2 to 4 inch amounts possible. And then the lower Hudson Valley, I think, could also do pretty well in the areas that get the heavy banding, 3 to 6 inches and locally 6 inches plus. And then further in, then it's just going to be a monster of a snowstorm. That's really, of course, still not getting talked about by a lot of the outlets, and I think they're going to be playing catch up throughout the day. We don't want to use the verbatim 10-to-1 ratio snowfall maps, though, because again, the snow may not be accumulating all that efficiently. But again, we can take a look at how the banding is affecting the temperature output on the models. You see the 35-degree contour on the high-resolution Canadian crash as well to the southeast. So within most New Jersey and New York City, 17Z, which is at noon, you're at 34 degrees or even cooler, anywhere between 32 and 34, which can certainly be cold enough for snow when precipitation is falling heavily. So it's not erroneously surging the temperatures in the low levels of the atmosphere. This model is more efficiently cooling the temperature towards the dew point. So yes, it's not going to be below freezing where snow is going to rapidly accumulate and you're going to get 10 plus inches of snow like some of those snow maps are showing. No, that's not the case, but there's going to be a few inches of snow in some spots combined with very windy conditions, leading to quite a hectic late Friday morning and Friday afternoon. So that about does it for this video. Of course, there's coastal flooding and a lot of other stuff that we could talk about, but then this video would get into like a half hour long, and it's really such a fascinating storm to track from a meteorological perspective. It's going to lead to a lot of surprises in some areas. Localized snow maximums, localized snow minimums over a very short distance. Widespread power outages in some areas, tree damage with the strong winds and particularly moist topsoil. So really a myriad of hazards to be expected across the entire area. So please stay safe during the storm. I know it sounds a little over the top to talk about safety sometimes with the weather, but really it's no joke with a storm of this magnitude, the very strong winds and the heavy rain and heavy snow. So again, please stay safe and have a good day, and we will keep you updated on all of our social media platforms.